Good afternoon, students. Today I'm going to discuss with you the Maxwell's fourth equation, right? So this is the Maxwell's fourth equation. Del cross H vector is equal to J plus curly D by curly T. Means curl of H vector is equal to J vector plus curly D vector by curly T, where D is the displacement vector. Okay, according to Ampere's circular law, the line integral of B dot dl is equal to mu naught I, right? Also, J vector is equal to di by ds, or current per unit area, right? So take ds to this side, di vector becomes J vector dot ds vector, right? Now integrating this equation to both sides. After integrating, the di part becomes I, means we just integrate the small elements of I vector, di vector, and by integrating all the elements it becomes complete current I, that is equal to surface integral of J vector dot ds vector. This is surface integral of J vector dot ds vector. Now put this value of I in equation 1, right? Put this value of I in equation 1. After substituting this value in I, you will get B vector dot dl vector, or line integral of B vector dot dl vector is equal to mu naught into surface integral of J vector dot ds vector, right? Also we know that this B vector is equal to mu naught H vector, mu naught H. So after putting the value of B here, mu naught H, take mu naught outside. Mu naught is called permeability of free space. Okay, this mu naught and this mu naught, this both mu naught cancels with each other, right? Okay, then we can say the net equation becomes line integral of H vector dot dl vector, that is equal to J vector dot ds vector, or we can say line integral of H vector dot dl vector is equal to surface integral of J vector dot ds vector. Now apply Stokes theorem on left hand side of this equation. Apply Stokes theorem. What is Stokes theorem? Stokes theorem converts line integral to surface integral, and it converts vector to its curl, right? It converts vector to its curl and line integral to surface integral, and vice versa, we can say. Okay, now apply Stokes theorem on left hand side of this equation. Okay, after applying Stokes theorem, H vector dot dl vector becomes at del cross H vector dot ds vector, and surface integral, line integral to convert it to surface integral. Okay, now what you have to do, take it as a second equation here, and this becomes third equation, right? This is the third equation. Now put the value of this equation. Also we know that H vector dot dl vector is equal to this thing, and in the second equation we can say the H vector dot dl vector is equal to J vector dot ds vector, right? Now equating these two equations, second and third, then after, or we can say that putting the value of this equation in equation 2, the two equations becomes, net equation becomes del cross H dot ds is equal to J vector dot ds vector, right? So surface integral of del vector dot H vector dot ds vector is equal to surface integral of J vector dot ds vector. If surfaces are arbitrary, remove the surface integral sign, you will get del cross, or del vector cross H vector is equal to J vector. And one more thing you have to remember, if I will make mistake it somewhere else, you just put yourself and take your right. Means here del is a nabla operator and del is a vector, right? So take vector on this. I just made a mistake here. Del is a vector, del vector cross H vector is equal to J vector, and this is for steady field. This equation is only for steady field and steady current, we can say, right? For time varying current, Maxwell took into consideration another current density. Actually our aim is to find this net equation, net Maxwell's fourth equation. Our aim is to find this Maxwell's fourth equation, this one, right? So we had obtained only del cross H is equal to J vector. Again there is some improvement, then some missing term, that is this thing, right? So that equation, that Maxwell's, this equation is for steady field and steady current, right? For time varying current, Maxwell took into consideration another current density, that is JD, right? This is one current density and another one is JD vector, right? Maxwell took into consideration this, and why there is a need of modifying this equation, why there is a need of modifying this equation, what is the need, why there is a need. So if we take, we just make a heading need for modification, right? Need for modification, we again took this equation del cross h vector is equal to j vector. Now take divergence to both sides. If we take divergence, del dot of this equation is equal to del dot of this equation, right? Del dot of del cross h vector. Also we know that divergence of curl of a vector is 0, so net result of this equation is 0, that is equal to this equation, that is del vector dot j vector. Means del dot j or del vector dot j vector is equal to 0, but equation of continuity says that del vector dot j vector is equal to minus curly rho by curly t, right? Equation of continuity says that del vector dot j vector is equal to minus curly rho by curly t. So there is a contradiction between these two equations. We had obtained del vector dot j vector is 0, but equation of continuity says that del vector dot j vector is minus curly rho by curly t. So there is a contradiction. So equation should be modified, means this equation should be modified. If this equation should be modified, so that is why there is a need of modification in this equation. This is the main thing, that there is a need of modification. Now what is the modification? Second concept is, what is the modification? So make a heading, what is the modification? So Maxwell didn't know the modification. He took JD vector. He took JD vector and he added this JD vector in this equation, del cross H is equal to J vector, that we had obtained in the previous session. Here we can say here, right? So he took JD vector, added to this equation, right? He didn't know what is the modification. He took JD, added to J, this equation. This means, suppose let del cross H vector is equal to J vector plus JD vector, right? Take it as fourth equation, right? Now take divergence to both sides. Take divergence means del dot of this equation is equal to del dot of this equation, right? But we know that divergence of curl of a vector is 0, right? So this equation becomes 0, is equal to this equation, del dot j vector plus del vector dot jd vector. Okay, now what you have to do, this del vector dot jd vector, take it here, or you can say take it to left hand side. Take it to left hand side. When you take it to left hand side, it becomes negative, means del dot j vector is equal to minus del dot jd vector. Take it as fifth equation, right? Now but del dot j vector, here in equation of continuity is applied. Equation of continuity says that del dot j vector is equal to minus curly rho by curly t, and also del dot j vector we had obtained in equation 5 minus del dot jd. So equation 5 and this equation of continuity, comparing equation 5 with equation of continuity, you will get minus curly rho by curly t is equal to minus del dot jd, right? Now from Maxwell's first equation, what is Maxwell's first equation? That is del dot d is equal to rho. So instead of rho, you just put del vector dot d vector from Maxwell's first equation, right? Okay, curly by curly t is equal to del dot d vector is equal to del dot jd vector. Okay, take del dot to outside, del dot curly d by curly t is equal to del dot jd. Now what jd becomes curly d by curly t. Now we took Maxwell's took JD, added to J. Now for our final equation, or equation 4 becomes del cross H vector is equal to J plus JD, where JD is curly D vector by curly T. This means del cross H vector is equal to J vector plus curly D by curly T. This is called Maxwell's fourth equation, right? This is Maxwell's fourth equation. Now what is the importance of Maxwell's fourth equation? First importance is that it relates magnetic field vector with displacement vector. Second, here time term is included, so second important is that it is a time dependent equation. Third importance is it summarizes Ampere circuital law for varying current, also called Maxwell's Ampere's law or modified Ampere's law, right? And fourth important point, or fourth importance is it tells that electric field, or we can say it tells that electric current density, that is J vector, is a source of magnetic field, right? Electric current density is a source of magnetic field, which agrees well with rested experiment, right? And fifth point is it tells that time varying electric field is the source of magnetic field. Time varying electric field means this thing is a source of magnetic field. Here we can say D is vector is equal to epsilon E vector, means this is a time varying electric field, and this is a source of magnetic field in space, right? So this is the Maxwell's fourth equation, and all the Maxwell equations are very important for paper point of view, so you just do it very seriously, or you do it completely, or we can say the question is like derive Maxwell equations. It may be of 8 marks, it may be of 6 marks, it depends upon the examiner. So just take it very sincerely, right? Thank you very much.